Good to go.
All right. Well, hello, everyone. Thanks for joining our Tech Talk this Friday. I am Regina here with the Tech Academy. And if you haven't heard about us, we are a technology school in Portland. And we just prepare students for different jobs, just technical positions. And if you want to learn more, you can check us out at learncodinganywhere.com. I'll also put that in the chat box. Also, today we have Trevor Spielman, who's here from In Time Tec, who's going to give us an awesome presentation on how to succeed as a software developer. So thank you for being here, and take it away.
Absolutely. Love being here. Love giving these presentations. A little bit about myself. I graduated from a boot camp about 4 years ago now, and it was a local one here in Boise, Idaho, which is where I'm based, as well as where In Time Tec is based. Loved my experience going through the boot camp, gained so many valuable skills, learned so much in such a short period of time. It really was like drinking through a fire hose the entire time, and I loved every minute of it. And after jumping into the workforce from boot camp, I really realized that there was a lot that I learned and a lot that was really different in the workforce than, my time in my classroom and everything. And so hopefully a lot of those concepts are in this slide that will really help benefit all of you as you make that transition after graduation, or if you haven't quite gone to boot camp yet, you'll kind of know what to expect, not only during your time in the boot camp, but also as you exit it. People are doing a great job turning on their videos. If you're comfortable, I ask everybody to turn on your videos because I love giving presentations to people versus pictures. So if you're comfortable with it, go ahead and turn it on. If not, fine as well. And then as Neil asked earlier, if you have any questions on any of my slides or the concepts that I'm presenting, go ahead and pop your questions in the chat. And I have that open up right here as well so that you can see it, or so I can see it, and I'll answer them as they crop up. Real quick intro about In Time Tec as well. Neil, I'll get to your question too. In Time Tec is a software development company, and we have two sides of our company. One is we do staff augmentation, so people come to us needing just more manpower, a certain set of skills, or consulting services for their own company and their own software product. And so we have a blended model where we have our office here in Boise, and then we also have a couple of offices over in India, and we create teams of onshore developers and offshore developers to really join our partners' companies. We're, for all intent and purposes, part of their company. My badge says staff. It doesn't say contractor. It doesn't say, outside person coming in. And we join and integrate with their teams and build software alongside them. Neil, my camp was 3 months long. It was full-time, so about 8-9 hours a day in the classroom, plus whatever work I did outside of that. And there was a couple of different focuses on it. We learned HTML, CSS right at the beginning, JavaScript, vanilla, and then JavaScript within the Vue framework with NoSQL backend. And then at the end of it, we learned C#, .NET framework, because .NET Core hadn't come out quite yet, as well as SQL backend. And so that was the standard curriculum. We only had one class at the time. That was really the only track that you could go through. So focus was really on building web applications. All right. There's no other questions to kick it off. I'll go ahead and get started. So next few slides and the presentation, like I said, are concepts that I've found and other developers at In Time Tec have really found help us be successful as a software engineer after graduation. And that includes college or boot camp. We have a mix of boot camp graduates as well as computer science, computer engineering graduates from traditional universities and colleges. And again, just recap, In Time Tec, we're a global software services and products company. And we really, like I said, have partnerships. And we say partners, we don't say clients, we don't say customers, because we really do try and create partnerships that last years, not limited to like one project, one product, or short-term goals. We really look to have vested partnerships that last year over year over year. And we have some that are coming up on 10 years almost of consistent engagement and partnership. So we have many centers of excellence, and we're expanding each one of these more and more as we grow. So our bread and butter, I would say, is software development, landing in that web and mobile development realm, as well as the DevOps or test automation and QA realm. Those are probably the largest segment of our services, and we are really growing our DevOps and our data science segments as well. There's a huge demand for those in the companies here in the Valley, as well as state governments and other institutions like that that really need, especially DevOps, pipelines to deploy, test automation to make sure that there's no breaks during the deployment, that sort of thing. So what makes a successful software engineer? Biggest thing, have you ever tried explaining it to the rubber duck? And does anybody know what talking to a rubber duck even means? See some head nods. So rubber duck, it's one of the best techniques that was ever presented to me. Is some engineers will literally have like a rubber duck sitting on their desk right next to them. Oh, great. Yeah, you got a little scorpion. I got a little elephant that I got while I was in India visiting the rest of my teams. And it's really just a device to help you work through your thought process. And so explaining it to the rubber duck lands during debugging sessions or when you're developing a feature. And if you're having a hard time getting the code to do what you want it to do, or figure out where the bug is hiding, right? One of the best techniques that I've found is that you just talk out loud, right? And that's what explaining it to the rubber duck means. In plain English, like the rubber duck is somebody who doesn't know what you're doing, how to program, anything like that, and you just explain what you want to do. And it can be as simple as like, okay, I need to write this if statement that is checking, XYZ conditional, and if, it is true, then we're going to go into this for loop, which then is going to iterate and so on and so forth. And you explain it as simple terms as possible. And that really, I found, breaks you out of the kind of analysis paralysis that your brain can get into of needing to write it all in one big chunk, and allows your brain to kind of start to break it down into those simple steps, just like you'd be explaining it to a 5-year-old. And why is that important? Well, because the pain of software development and the pain of a company and the cost to a company is not in the writing of the code. It's the bugs and the defects that get presented during the writing. So the cleaner code that you can write, the more simple that you can explain your code, the more simple that you can write your code, decreases the number of bugs that are likely to crop up in it. And as you can see by this graph, if the defect is found in the testing or the support stage, it's too late. It gets a lot more expensive. If you've written code, taken like 3 days breaks, sometimes even like a couple of hours, and you go back and you reread the code that you just wrote, sometimes you don't even remember like what it's supposed to do or why you wrote it the way you wrote it. Happens all the time to me. Just think of that like weeks or months down the road, and you revisit your code. And you're like, oh, yeah, I did write this. Don't remember why I wrote it this way. And so if you can reduce the number of bugs as you write the code, you don't have to go back and reread it and try and figure out why the bug's there. So successful software engineers have the following. They have a discipline to write code cleanly from the beginning. And I say discipline because it's very hard. It's very easy to get into the mindset of making it work and then thinking that you'll refactor it later. And that's a huge fallacy, because you're likely not going to have time to go back later and refactor it majorly. So write it cleanly from the beginning. Andrew, great question. So developer, that's my next point. Discipline to test and validate code before submitting your PR. So as a developer, you need to be testing, you need to be writing your unit tests. Sometimes you'll need to be writing your automated tests, but hopefully your code is as clean as it can possibly be and as defect-free before it even reaches QA. And hopefully QA is only catching those edge cases where, it's just nobody can think of every possibility, right? But as a developer, no defect should crop up in your code that is in the main line of behavior of the user, right? So if a user is supposed to click a button and it's supposed to submit your contact form, no defect should happen in that main line of clicking the button and the contact form going through. Maybe a defect arises if they click it 5 times and it breaks something. That's unusual behavior. That's something QA might want to catch. So yes, testing is very much developer driven, always. As developers, doctors have the Hippocratic Oath, first do no harm. Developers should as well, right? If we jump into a code base, existing or new, we should always be thinking, first do no harm. Don't break anything that's existing. Don't break the design pattern of the code or the functionality of the code. And then in order to do all of this, you need to practice your craft outside of work, right? Be reading books, be reading new languages. You don't necessarily have to learn them, but you can explore them. See how new languages and frameworks, organize themselves, because that'll give you insight into how you can organize your own code in the framework and language that you're working within. But always be kind of looking out, seeing what's out there, seeing what's new, and that'll help keep your edges sharp and keep you writing code that is progressively better and better. Rose, not super familiar with the Thin-Min method, but teaching the concepts you learn in a way that definitely the way you explained it is what the rubber duck is all about. Yeah. Neil, that continued education, boot camps only have a finite amount of time to teach, and what I would recommend is just looking at Pluralsight, YouTube, and just finding a unit testing framework and just delving into it. A lot of developers that I've run into, especially from boot camps, always have this concept of man, I know how to develop, but I don't know how to test. Testing is developing. It's the same thing. We'll get into it a little bit, but test-driven design will really kind of show you that testing is no different than developing a feature. It's just a little bit different. Writing pseudocode, Rose, common practice on the job for some. Yeah, absolutely. I like to stub out my code. If I'm writing a feature, I like to stub out the steps in pseudocode first. That kind of helps me maintain my structure and refine my thought process. So I think it's a great practice, kind of for each their own. There is a couple of concepts. One's called emergent design, and the other one's called successive refinement. And emergent design, you wouldn't really write pseudocode. You kind of start writing, and your design emerges as you're writing it. You're building the plane as you're flying it, as the saying go. And successive refinement is you write a first iteration. It's like writing an essay, right? You write your rough draft. You go back through, you edit it, and you refine it, reread it, edit it again. That's successive refinement. And that's kind of how I approach my code, is that successive refinement. I get it to where it works, and then I go back and I kind of fix where I break the design pattern or the single responsibility principle, that sort of thing. So some people like to ask, what is clean code? At the simplest form, clean code is the number of WTF moments per minute, right? And this is when you're reading code, either yours or somebody else's. And as this little graphic demonstrates, you're in your code review and you're reading it, you're just like, what the heck is this? What is that? Like if there's too many of those moments, it's probably not clean code. And it needs to be clean because as you get into the industry and into large projects, 70–80% of your time is probably reading code, not writing code, because you have to read what's all around you before you can write code, because you have to understand what's already in place, what common functions are there before you can write your function, so you're not duplicating code, or you're not, writing code in the middle of another thing that breaks it. Stephen, great question. Lands right in here. Comments are a great topic of debate. Comments are tricky. On one hand, they can provide clarity and kind of explain what a function is doing. On the other hand, your code should be clean and descriptive enough that somebody can read it and understand what a function is doing without the need for a comment. And where a comment really becomes problematic is that almost universally, and I'm never going to give you absolutes, but almost universally, when a developer goes in to change the functionality of an application or add functionality, they may edit the code, but they likely won't edit the comments. And I can't tell you how many times I've been reading through code and the comments that were left did not reflect the functionality of the code that they were supposed to be describing. Either somebody wrote a function in between the comment and the original function that it was supposed to describe, or the functionality changed so much that the comment is no longer accurate and just nobody thinks to update them. That was a much more common incident than the comments actually being accurate to the code, in my experience. So comments have their place, but clean code is always much, much better. Good question, Sean. I couldn't really tell you how often. I would say as little as possible, personally. Maybe only where there is a kind of inelegant way of implementation and you kind of document why you did it that way. But even then, hopefully you're not running into that scenario. You might comment why a model is a certain way if there's like 2 IDs on a class or something like that, because the data set that you're working with just wasn't developed very well and you're dealing with it. But again, comments are one of those things that are just very susceptible to becoming more problematic than they are useful. So hopefully the code is written cleanly enough that any new developer comes in and can understand it, and there's documentation to the extent that comments are kind of not necessary. So clean code is kind of opposite of this. So bad code can be described as a mess, spaghetti, brittle, a nightmare to work in. Has anybody ever heard the term spaghetti code? Great, perfect. Spaghetti code, does anybody know why we say spaghetti code? Has anybody ever kind of understood why that is? Has anybody tried to follow one piece of spaghetti all the way through the pile in a pile of spaghetti? Just by your eyes, not by like pulling it or anything like that. If you have, how successful was it? Probably not very. And that's what spaghetti code is like, is trying to follow one line of data going through an application. And if it's poorly written, it looks like spaghetti. You get lost. It's really hard to follow. You don't know where you should jump in to make an edit, that sort of thing. Whereas the opposite, clean code, is often described as elegant, expressive, and reads like text. There's only one place that you need to make a change. Easy to maintain. Of GIGO, I haven't heard of GIGO. That's a new one for me. Neil, I'll come back to those questions at the end. Yeah. So again, when we're talking about being successful outside of Code Camp, we're really talking about habits and disciplines is the best way to put it. And I'm not going to read all these out. I'll share this slide deck so that it can be distributed out so you can use it as reference. But really, to be successful, you develop habits of writing clean code and being a clean coder. And those are some separate habits. But some of the key ones is quality is the responsibility of the developer. You need to bake the quality in. As the writer and the maintainer, the less quality that you bake into your initial code, the more maintaining you're going to do. And maintaining is not fun. I don't like bug hunting. I like eliminating bugs, but I don't like trying to find bugs. I love writing features and pushing new functionality out to clients. That's the fun stuff. Developing something new, building something from nothing to something. So the more of that you can do, the more fun you're going to have. The more maintaining and bug hunting that you have to do, probably the less fun you're going to have. Unless you're a QA person, and then bug hunting is your job, and there's a lot of joy in that. But be a Boy Scout. Leave the code better than when you found it. There's a lot of code points here. Really, these books encapsulate it. So in Time Tec, we have a learning group that every new developer joins when they join the company. We call it Learning Code, and we use Clean Code, this book right here, as the foundation for that learning group. And we really go chapter by chapter and talk about the concepts. And they go through, naming conventions. It talks about comments, when to write them, when not to. It talks about how you should structure your functions, your classes, and everything like that. If you haven't read the Clean Code, highly recommend it. It talks about the code itself. The second one, the Clean Coder, is more about you. So how do you be a professional programmer and get the job done, but also do it in such a way that you're not leaving yourself out to dry or vulnerable. So it's like how to say yes to things, or when you need to say no. What it looks like just to be a professional programmer. How do you manage your time? What should you do if you're really stuck with a bug and can't figure it out? When to walk away. Just a couple of quick books for code specific. Code Complete is considered one of the best practical guides for programming on the market, and it has a great section for practical examples where you actually dive into the code. There's a GitHub repo for it, which is linked later down in this presentation. And then Practices of an Agile Developer. Almost, again, no absolutes, but almost universally people have adopted the Agile Scrum methodology. Waterfall still exists, but not nearly as prevalent as the Agile methodology. So being familiar with that and knowing how to be a developer within that system, very useful. And then soft skills. Software development is no longer sitting in a cave and hunched over typing code until 2 a.m., drinking Mountain Dew and eating Cheetos. All the stereotypes from a few years ago no longer apply. Software developers are now teams, and those teams include Scrum Masters, project owners or product owners, and maybe other people. So a lot of soft skills are required now of engineers to be able to explain what they're writing, why they're writing it the way they are, whether or not they're going to meet the deadline, and being able to explain that, no, we're not going to meet the deadline, and this is why. This is the new deadline that we can meet and commit to. So there's a lot more conversation, a lot more planning, and just a lot more kind of presentation of the work than there used to be. So this quote kind of comes down to that quality is baked in, and you'll see that theme kind of repeated in this presentation a few different times. And the quality should already be there before it's being inspected. So as the developer, we're responsible for that quality before QA jumps in and starts digging through our code. Like this says, you can't inspect quality into a product. And if it's not there, by the time it's inspected, then it's not existent. And this is really important because it's much harder to have a conversation with your product owner or the management, whoever's client facing, and say, hey, we need to delay providing new features and a better user experience to the customers by a couple weeks, a month, 3 months, whatever the case may be, because we didn't write this code in a sustainable way. And now we need to go back and refactor it so that it is more sustainable and we can continue moving forward. There are a couple of pretty telling examples of companies that had an amazing product, pushed it to market very quickly, and then it failed shortly thereafter. It was kind of like a spike and then a quick drop off because they wrote the code in such a way that got it out quickly and customers loved it. So they kept adding more customers and requesting more features. So they added them on and on and on and on. But they were so focused on the feature development that the foundation crumbled and they could no longer support the system. So releases got delayed, more bugs were introduced, and the cult following that they gathered right at the beginning dropped off because the user experience wasn't there. And that's happened quite a few times. So tests, we asked about it. Who's responsible? Developers are. And your project should, at the very minimum, have unit tests. If it doesn't, it's a conversation to have with your product owner and your Scrum Master. Unit tests are a safety net. They provide security, they provide automated checks, and they provide documentation of your code. So unit tests are there to not just greenlight the code that you wrote, but really protect the structure and the sanity of your code as you're adding new features to it. Without tests, if you add a new feature, you kind of hope and pray that it doesn't break something else. And you might go through the application on your local host and kind of click around and, check all the major pathways to make sure nothing's broken. But you don't have the time to do like a full regression where you're clicking every button, you're executing all variants of a contact form, and doing all that. You don't have time for that. But by writing unit tests, you don't have to do any of that, or at least to the extent that I'm describing, because the unit tests are there, and if one goes red and it fails after you've added functionality, you broke something. Or at the very least, the warning to look at why did what you changed make one of your tests fail. Second, or the third point, documentation. Tests don't necessarily abide by the rules of software development in the fact of when you're writing a function, the name needs to be descriptive, but it also needs to be kind of short and sweet and to the point, right? Because you don't want somebody reading your function name for too long and kind of losing their flow in the code. But in a test, you could absolutely write a test name that says, testing the functionality of 2 + 2 = 4 or something along those lines, and have very long descriptive names in those tests, because it doesn't have to be so succinct in the code. And that's where the documentation portion comes in. If you have a lot of unit tests, those are the place that you look to see what a function is supposed to do and what it's not supposed to do, if there are good unit tests there. Without it, then you're just looking at the function, right? Marlon, I'll answer that at the end as well. Great question. So when to write tests? A couple of fields of thought on this. Test-driven design, also known as TDD, goes under the guise of all code is guilty until proven innocent. So all code won't pass a test until it passes a test. And test-driven design is design where you're actually writing your unit test before you write your feature code. So the point of TDD is you write a unit test to the point where it fails. So your first step is writing like a function, and it'll fail right away because there's nothing in there. And then you write your feature function. You go back to your test after it's passed and you write some logic in there, again, like 2 + 2, you pass in the parameters. It fails because your feature function doesn't have any parameters, so on and so forth. And it's this cycle of just very short, write part of the test, write part of the function. And this does so many different things. One, you can never write code that's not testable or tested. Two, it helps maintain short, succinct functions because you are writing in just very small, deliberate steps, right? And then three, single responsibility principle. You know, your function should do one thing, your class should do one thing, your variable should only represent one thing. In test-driven design, it's very easy to maintain that because tests can only really test one thing before they become really unwieldy. And so it's another checkpoint to make sure that you're not writing a function that's so complex that's trying to do like 5 different things, because your test is going to reflect that and it's not going to be able to be tested. Why is this important? Well, we talked about the pain point, right? Pain point comes in the code where the bugs are introduced. And if it's caught in QA, it's too late. There was some studies done on test-driven design. It's a very odd way of thinking how to write code for some people. But IBM, Microsoft, well, just those two really, did a test. And they implemented test-driven design and measured how long it took to implement features versus the defect density, so defects per feature that were introduced. And you can see, you know, on average, we're looking at like 120%, 125% additional, you know, time to develop the feature. So a little bit longer, but the defect density at worst dropped by half, just a little over half. At best, dropped by almost 90%. So we're talking like 10 defects down to 6, or 10 defects down to like 0.9, right? Huge drop in defects, and that's amazing because defects not only impact the developer, they cost money, they impact the user, they impact management. It's just not a good feeling to have. So, like I said, I'm sharing out this slide deck. This link is just a video of somebody demonstrating test-driven design. I'm not going to play it here, but it's a great idea, or a great example of what it looks like to write in that style, because again, it's very different from what many people learn and try. So I mentioned Code Complete, the book, and this is one of the GitHub repos that it provides. So these are all coding checklists to help bake quality into your code. And you can see the Code Complete has one for a whole bunch of different aspects of code. Loops, for loops, pair programming. How should you pair program? How should you write pseudocode? You know, we asked about writing pseudocode. What are some quality guidelines that can be done while writing pseudocode to make your, you know, your actual code better? Test cases. And each one of these links to a checklist. And here's the class quality checklist. So for every class, do you have a central purpose? Is it well named, and does that describe the central purpose? Is the class hiding its implementation details from other classes so that, you know, you're maintaining encapsulation and inversion of control? So just ideas, again, as you're developing as a programmer, nobody expects you to know all this right away. This is all, programming is a lifelong endeavor of improvement. And these resources, checklists, ideas are all things not necessarily to like know when you go into your job, but at least know that they exist, and you can choose, you know, 1 or 2 of them to focus on 1 month, and the next month you add a couple more until they become, you know, habit. Again, we're talking about disciplines and habits here, not necessarily knowledge that you have to have immediately to be successful. So we've brought up a lot of things, and it's a lot to try and keep in your mind, as well as remembering how to code, as well as remembering, your dentist appointment and your Scrum meetings and everything else that you have to do as a professional. So what can we do to kind of take some of this load off of yourself, right? As a developer, we're only human. We can only do so much. One of the important things, have a style checker. So all three of these check how your code is written. Are you using tabs instead of spaces? Are your variable names really long, or are they short and succinct? Are you using var instead of let? Or if you're writing in a strongly typed language, are you defining your variable instead of just defining it as a variable instead of like an integer or a character or a string? These will check all of that. And the important thing about this one is, again, it's like reading an essay. If the essay is formatted all the same way, you can read it from beginning to end pretty easily, right? But if page 1 is formatted with, indents before paragraphs, and then page 2, there's no paragraphs at all, it's just all one page. Page 3, they, don't put periods in or something like that, right? It becomes very hard to read. And in a project, you have, 5, 6 developers minimum working on it. That's 5 or 6 people that are writing in their own style, who might indent differently. Maybe they put curly braces on a new line instead of at the end of the line. And these style checkers just kind of help standardize all that. And so when you push to your repo, the style checker will go through and either automatically make the changes in the case of like curly braces or tabs or indents, or it won't let you push until you meet the standards that the team has determined to begin with before you can push. But style's not everything. Your code itself has to function. And that's where a static analysis tool comes in handy. And REST Sharp is the one in the upper right-hand corner. It's for C# programming. IntelliJ IDEA is for Java. SonarQube is code agnostic to a point, as is Visual Studio and Cover-IT. And these are actually looking at your code itself. Is your function having too many parameters passed in? Are there 5 when there should be 3? Are there sections of code that are not even being accessed? They're written, but they're never used. That sort of thing. And this really kind of helps make sure that your code is adhering to certain quality standards that your team or your company has determined and implemented. And the lovely thing about these is that they're all automatic. Visual Studio runs every time you build. That's why you get warnings. SonarQube can be implemented in a CI/CD pipeline. So every time you push to your repo, it runs through SonarQube, and the push to the repo will be canceled if the SonarQube test fails, as does REST Sharp and IntelliJ IDEA. And all of these things are to prevent this kind of scenario. It's like, man, this code's terrible. Why is there global scope? And man, there's try catch everywhere. There's for loops inside for loops inside for loops. Terrible code. Oh wait, it's mine. Never mind, it's not bad logic anyways. The point is, like, it's all, what's the word for it? We each have our own spin on how we look at code and what we think is quality. And tools like these take that individual concept out of it, and it makes it to an agreed set of terms by your team of what's good and what's not, and what you're willing to commit to as a team to write good code. I'll talk for a couple more minutes, and then I'll break for questions, because the rest is kind of optional stuff to discuss. Repositories and version control. Always have this. That's all I'm going to say about this slide. It's an amazing thing to have. I have interviewed people who are responsible for their entire company's code, and it's on their hard drive and like a flash drive that they back up like once a week. No version control. I've met people whose companies, they pass their code by an external hard drive. So one developer will work on it one day, they save it to this external, and they pass it to the next developer, and they copy and paste it into the server to deploy. And this scares me so much because somebody loses the hard drive, employee gets laid off and is a little bit malicious, boom, there's all your code gone. And I worked with a company who got hit with a ransomware attack, penetrated the entire system, every server, every database, and many of the company's laptops were caught in this attack and compromised. And we had to shut everything down and start from scratch. And it's only because we had version control that was not compromised that we were able to bring up all of our systems, services, databases, and stuff back live. But even with all of that, it took close to half a year before every service was back up. And the biggest problem with that is because we didn't have a lot of documentation around some of these services, which were very old, and the developers who had worked on them had left the company. And so we didn't know how to bring them up or what dependencies they really had, because that wasn't documented and passed on. So version control saved us. Documentation, the lack thereof, shot us in the foot. Code reviews, again, helps maintain code. Better to have two sets of eyes on a piece of code than just one. And I always recommend this for anybody who's writing code. When you build it in Visual Studio Code or Visual Studio, you get warnings and you get errors. And most people ignore the warnings, but they're there for a reason. They may not be a problem now, but they'll probably be a problem down the line. And so where you can, just treat warnings as errors. It'll prevent your build, and it forces you to fix them before you go on. And it's just a good practice to not have warnings. It's like your check engine light in your car. Yeah, you could ignore it, and you could probably drive fine for another 1,000 miles. But then it breaks down and you're stranded. All right. The Scrum process, as I mentioned, almost universally, we are now in an agile Scrum format for many, many, many companies. No longer is it waterfall. And that's where this whole process comes in. Productivity at a sustainable pace. The saying is, you don't eat the whole elephant, you take one bite at a time. And that's what's true for software development. You don't build an entire application all at once. You build one feature, one feature, one feature, one feature. And that's what this is really all about. It provides the structure in which us as developers can really thrive, not become overwhelmed, and then pivot very quickly in case things change. Because clients almost always change their mind at least once during a process. And sometimes they don't even truly know what they want until they see what they don't want. And then they kind of get a better idea of what they truly want. The rest of the slides are just recommended readings. So I'm going to kind of skip over them a little bit because, like I said, I'm going to share this slide deck to be shared out to everybody here so you can kind of see the books independently. Because I really want to jump to some of these questions that you've asked in the chat for the last 10 minutes or so. So Neil, starting with yours. Tech background prior to my camp, very minimal. I graduated college with a degree in psychology and minors in human biology, criminal justice studies, sociology, and anthropology. So all of the soft skills in the world, not really a tech one in there. Statistics and using statistical software was about as close as I got in college to software development. From there, I went on to digital marketing and project management in a digital realm. And that's where I really kind of got introduced to code. I managed a team of developers, and I needed to know enough code to be able to talk to them smartly as well as talk to clients coherently. So when I went into my boot camp, I had some knowledge because I tried to teach myself for a couple of years and never was really successful. So minimal. Straight out of boot camp, why hire you over someone else with more robust backgrounds such as CS Grease? So that's a great question. I am involved in a lot of the interviewing and hiring for In Time Tec. And there are many roles that I would take a boot camp grad over a CS grad any day. In our area and many computer science degrees, they focus on the theory more than the practical application of software design. So when I've interviewed computer science degree graduates, they know data structures, they know design patterns, they know theoretically how to write code, but they don't necessarily have a robust portfolio of full applications that they've built themselves. Bootcamp grads do. That's part of bootcamp. You write a bunch of applications. That's how you learn. That's how you practice. So they come in knowing how to write features, knowing how to write a full application, but they might be light on the theory. So they may not know all the data structures or algorithms, how to write bit banging algorithms, stuff like that. So depending on the other skills, I love bootcamp grads. In Time Tec, we have far more bootcamp grads than we do computer science grads, especially in our web app development side of things. Other thing I love about bootcamp is that that there's a tenacity and a drive for anybody who's going through a bootcamp, because it's not easy. Going full time like I did for 3 months, pivoting from a career that paid well and going to an unpaid school for 3 months is a huge risk. So I always know that anybody who's made it through a boot camp is probably very passionate about writing code, very willing to learn new things, and very driven to improve themselves. What should a junior developer at least be able to do day one? Ask a lot of questions. It sounds like it should be an obvious answer, but that's something that we look for in our interviews, is how many questions are they asking us? Are they asking for clarifications on the requirements? Are they asking, is there a better way to write what I just wrote? Are they asking for help? Honestly, our interview process is a little bit unique. We have junior developers come in and do a technical challenge that takes about an hour for them to do. And one of the great signs that I love to see is they ask questions. If they get stuck, they come out, and we tell them to. We're like, hey, if you get stuck, come out, ask us. We want to talk through this with you. Because we don't expect junior developers to be able to write full functionality without some stumbling blocks or the need for some guidance. And so the developers that run into a problem, can't figure it out themselves, come out and ask us a question and get over that block, I value so much more than those who don't. And then I come in to see what they've accomplished, and their first answer is, well, I didn't get too far because I got stuck on X, Y, and Z and I couldn't get past it. I'm like, why didn't you ask me then? Why didn't you come out and ask a question? And they're like, well, I thought I could figure it out. Maybe you could have, but there's definitely a time period where you should give yourself time to figure it out versus you've looked as far as you can look and you just don't know what you don't know. So you need to ask somebody who's more experienced to come in and show you what you don't know. That way you're not blocked in the future. Much rather would have a junior developer ask 20 questions in a day than hold their tongue and come to the end of a sprint and not meet their sprint goals. My shirt, it's backwards. It says people first. That's In Time Tech's philosophy among, basically every level of our company. But as a senior developer in our company, our expectation is that you're joining us, and one of your responsibilities is to mentor and grow our junior developers. So if you're not being asked questions by junior developers, you should be asking why they're not asking you questions, and why you're not approaching them to help train them up. Let's see. Marlon, what mindset should you adopt after graduating a boot camp, going into a software developer job? Great question. What I found was that the learning doesn't stop. Boot camp taught me how to learn, how to code. And my first software development job taught me how much I didn't know and how much I had yet to learn. So going into that software developer job with the mindset that you're going to learn a lot, and that everything can be broken down into smaller pieces, and that you're probably going to fail a few times is essential. And don't be too hard on yourself. Junior devs, it's like any job. The sprint process can seem a little bit intimidating at first. Oh man, I only have 2 weeks to write this functionality, and then I have to go on to something else and write something else new in 2 weeks. No. Yes, the sprints are designed in 2 weeks, but they're also designed to be flexible for things to roll over. And it's only if that's happening constantly that it becomes a problem. But no company worth their salt is going to look at a junior developer and not expect some struggles or questions or missed sprint deadlines. It's a part of growth. It's a part of learning. Rose, as a computer science student, build a full stack application. Find something that you're interested in, or do something as simple as writing like a task manager, right? And so research a front-end framework and build the front end into that. Learn a design pattern like MVC, model view controller, and implement that. So you get your front end, you get your controller, you get your services with your models, and then you go into a back end, writing to a NoSQL or SQL database. Even just something as simple as, like I said, a task management, where you can add a task, edit, delete, do a simple CRUD application. And that way you kind of get the idea of like what a user does, how it flows through the application, how it's saved somewhere, and then how it's retrieved when that user comes back. And there's tons of tutorials everywhere online for it. Pluralsight is amazing for that. Free Code Camp, Code Academy, both have project-based learning, so that's a great place to start as well. Andrew, not uncommon for CS courses to ban IDEs, version control, automated builds, automated formatting. Oh, that's really unfortunate. Rose, did you have a follow-up question? You're unmuting.
Yeah. What is a full stack application? Forgive my ignorance.
Yeah, no, you're fine. Full stack just means you're writing the front end and the back end and the database. So when you say full stack developer or full stack application, it has a front end user facing side. So that's going to be like Angular framework, Vue framework, React. That's what you're interacting with as a customer. Then the back end is typically the services and what's talking to the database, right? So 3 kind of separate pieces to an application, they all stack together. Is that enough clarity? Or do you have additional follow-up questions?
Yeah, thank you so much.
Yeah. No problem. Yeah, it's really unfortunate, Andrew. IDEs are your friend, so is version control. Automated builds and automated formatting are all so common in the working world that there's no reason to shun them. There's really nothing benefiting you, in my opinion, from writing your code in Notepad or Notepad++ versus writing it in Visual Studio Code. It's part of the industry and their tools, right? So if you learn how to use them really well, then great. It's just like in construction. You don't see construction workers using a hammer and nail all the time. They're using a nail gun. And they're not looked down on because they're not, banging a nail in with a hammer every single time. They're being efficient, and they've learned to use a more advanced tool to better their craft. Field market is saturated for junior devs since my people boot camps during COVID. Maybe a little bit. Definitely COVID, I think, has pushed a lot of people who are on the edge of doing something like programming over that edge and into taking action. Saturated? No. There's always going to be companies that need new developers and are looking to hire. Tips for finding good companies that offer first dev jobs, really it's in the interview, right? What are they asking you to do? What are their expectations? Are they open to you asking questions? Are their technical assessments asking way too much of you, in your opinion? Because your technical assessment in an interview should reflect what you're being expected to do on the job, right? So if your technical assessment is like way too hard and you just either really struggle through it or you're not even close to finishing it, likely that company is going to be asking too much of you and you're going to be really stressed out and really struggling in your job. So be patient. Also, a lot of boot camps, like I said, are full stack. They teach you how to program, but that's only the tip of the iceberg. Learning to be an SDET, a software developer in testing, where you're writing automated tests, is not the exact same thing, but very similar to being a feature developer. You're writing logic of how to test, and a lot of people shun away from that because they want to be a software developer. But starting as an SDET and then moving your way into a software developer, great start. Great segue. You learn a lot of valuable skills being an SDET that you can transition into your software developer job. Some companies do integration specialists, and they're really responsible for helping like clients integrate into the company's software. And so it's like a lot of API calls, and some people would call it not like truly a software developer, but it is. It's still just another segment of software development, and it's teaching you skills and getting your foot in the door. So don't pigeonhole yourself into software developer. You have very tangible skills of learning how to program that can be applied in any of the different departments of software programming. Lars, do bootcamp students learn PHP at our bootcamp? Typically able to manage. Let's see. Depends on the bootcamp. I know some teach PHP. Mine didn't. It just taught JavaScript and C#. But PHP is still very valuable. Something like 95% of the internet's still on PHP because of WordPress. And it's actually probably a really good way to get your foot in the door, because a lot of people think PHP is legacy and kind of phasing out. And it might be, but there's still a ton of applications that need PHP developers to maintain them and build more features onto them while they transition to newer technologies. And that's one place that my company is hiring heavily in, is PHP developers. So yeah, definitely. And you can take any skills that you learn in PHP and apply them to different languages. Bootcamp students typically able to work with GitHub. We did in my bootcamp: GitHub, GitLab, Bitbucket. We kind of learned all three of those, and they're all about the same. Jay. Yeah, so I did have a desired path. I wanted to be a feature developer. I really enjoyed that. And specifically, I wanted to be a front-end developer because I really enjoyed the client side, making that button and being able to click it, stuff like that. And did it change on the job? Yeah, yes and no. I still love front end, but I have a really great appreciation for a well-built back end. And in my experience, the majority of my work actually ended up being in the back end because the front end was already built. It was an existing software, and there weren't really many changes that were being done to the user experience. And so everything that was being developed was in the back end, pretty simple front end changes to allow for a more robust back end change. So that changed. I really enjoy the back end now. I love DevOps. I've gotten into that, and that's really fascinating. And that's more scripts and kind of network management almost. So, yeah. Build up confidence. Neil, I'm just reading your question. It's a great one. Without saying build project. For that, again, some of those tools, Pluralsight, Free Code Academy, and Free Code Camp and Code Academy, they're project-based learning. Still, they teach you step by step in the project, which may seem like hand feeding, but then my recommendation would be like, take that and do that project, but something adjacent to it. So say it's a task list, right? And instead of maybe a task list, build a roster like a team management system where it's kind of the same functionality, but then build it from scratch and see if you can like build it with guidance and then reconstruct it from memory, right? And use the project that you built by guidance as like a reference point if you get stuck. Because if you can do that, then you can build almost any application. It's just kind of the repetition of how to build it. Writing code is similar to building like a house construction. You get your blueprint and you kind of follow it. You learn how to measure, you learn how to cut, and then how those pieces kind of fit together. And then through repetition, you become faster and better and more flexible and creative with it. Really I would apply, honestly, and use that as like a litmus test of where you're at. And if it's your confidence of starting a project from scratch, then looking at framework documentation and their tutorials is a great place to start. Because they'll always have you start a project from scratch and then do their tutorial. If it's complex logic, then you can use applications like Code Wars or LeetSpeak, I think, is the other one, where you're answering kind of trivia questions almost in code, whiteboard style questions. And so just kind of the repetition of that kind of builds your confidence. But yeah, did that answer your question?
Yeah, it did, but I was just thinking, I don't think that my GitHub repository accurately represents my abilities. Do you think I should take down some of those projects because they were hand-fed to me and I couldn't recreate them?
Nah, I'd leave them. Honestly, the best thing from that point is create a portfolio site, and GitHub allows you to have like a freely hosted portfolio website. So if you don't have that, that's a great place to start. And that's where you can really only link to the projects that you want interviewers to see. They may go further back, but I can tell you, the average resume gets like 6 seconds of attention. I can tell you your GitHub profile gets probably less than that. I have never looked deeply into a candidate's GitHub profile. Our interview has them bring a project that they want to share, and we walk through the code and we walk through the front end, the user end. And then we have our technical challenge, and then we have like Q&A after that. And it's through that whole process that I get enough information to know, is this developer going to be able to adjust and write code or not? Or is there going to be too much learning that's going to have to happen before they become productive to be successful? Oh, Rose, excellent. Yeah, it really is. A lot of people think development and software programming is some like mystical activity, but it really is just writing. And it's like the simple things that you build on top of each other that make something complex. At the end of the day, every single application that you ever see online is just movement of data. A click, a contact form, something that you've typed. It's just movement of that action through an application to a database or some other service that then triggers something else and presents new data to you. And Rose, I'm just reading your other comment. So this might be too open of question. Fascinated by operating systems and computer architecture, learning what makes Linux work since its source code is open and free to examine and edit. What is a good direction to take in terms of looking for experience and work? So that's a really interesting one. So that kind of gets into the conversation of a great majority of jobs right now are web app. Internet is everything. Almost everything's hosted on the web. But we still work on computers, and that's firmware, and that's software, and that's an entirely different discipline and set of languages. So where web app is built in like JavaScript, C#, Java, TypeScript, HTML, CSS, computer application development and firmware application development is in like Objective-C, C++, that sort of things, the assembly languages. So you can start looking into those kind of languages. I am much less familiar with that world than I am web application, though, so I can give too terribly much guidance for that. You can look into C#. Microsoft obviously has the operating system and everything, and in Microsoft's documentation and C# language, there are ways to build desktop applications using C# language. So that's could be a starting place for you to look, and then you can kind of delve deeper in from there. Great questions. I know we're over time. Is that all right? I know we're like almost 15 minutes over time.
Yeah, we're fine.
Perfect. Yeah, any other questions? I'm open, so I'm happy to answer any more that come my way.
Well, I do have a comment to make, Trevor. I am really glad you brought up the clean code books. Those are, I highly recommend those. And the author, Robert Martin, he's got a lot of videos on YouTube that are really good. He does a lot of talks to universities and colleges. So I do highly recommend those books. And the single responsibility principle is really important.
Yeah, great addition. Yeah, single responsibility principle. I brought it up a couple of times. I didn't really explain it too much. So we have the solid principles, which you should learn. And I won't get into those too much, but I would say as a junior developer, one of the most important things you can do to take your code up the notch and have it be much more clean, much more readable, is the single responsibility principle. Learn it, abide by it, and apply it. So single responsibility is, as I mentioned earlier, your function should only do one thing. Your unit test should only be testing one thing. Your variable should only represent one thing. And hopefully even at a higher level, your class should really be only responsible for one thing. And so if you're getting into your code and you're writing your function and you're passing like an if statement into like a check for validity or math, and then it's going in after it passes that check and being sent to a service, which is then being received back, and then something else is doing it. Like if your function is trying to do 5 different things all at once, or like stacked inside the same function name, that's bad. Hard to read, easy for bugs to crop up, and when they do, it's really hard to debug inside of that function because you don't quite know what's causing the break. And this is probably, for me, one of the most important parts, is it truly limits your ability to be expressive in writing your code. We talked about, comments not being super useful. And if you have a function that does 5 different things, you almost have to write a comment because it's so hard to read what those 5 things are inside of the function. And so you almost have to write a comment that says, this function does X, Y, Z, instead of having 5 different functions where their names are expressive of what they're doing, and you're just chaining them together. And then when you have to debug, that debugger will go right into a single function, and you edit that one spot instead of having to change the functionality of a 5-function or a 5-function function, which might break the other 4 things that it does because you have to edit the type of data that it's accepting or something like that. So the more that you can read and understand the single responsibility principle and apply it, the cleaner your code's going to be, and simpler to explain, simpler to read, more expressive, easier to debug. I mean, just so useful. Start small. Start with your functions. Start with your variables. And then you get comfortable with those, build it up. Classes do one thing, represent one thing, and go from there.
Yeah, it's a great philosophy to approach.
Yeah.
All right. Any other questions? Regina, do you have any questions?
I don't have any questions. I just want to say that was really informative. I myself learned a lot from this presentation. I'm assuming everyone in the meeting also did as well. Also, a side note, just to let you know, we have our Tech Talks every Friday. And next week we have Dan Ling coming in to do one on imposter syndrome. And I'll leave it in the chat box if you want to RSVP for that one. But if there are no further questions, all right. Well, thank you so much, Trevor. That was awesome. And also, if you want to, I'm going to later post this recording on YouTube, and I can also leave the link to our Tech Talk playlist so you can watch it back later.
Yeah, great talk, Trevor. Really good information, and I think it's going to help our students a lot. There were a lot of questions, so I think that shows how good your talk was.
Well, thank you. Like I said, I love giving these. Feel free to find me on LinkedIn and reach out if you have any additional questions. And if you're interested in In Time Tec, the link's in the slide. Our jobs are all posted on LinkedIn if you want to apply. We are allowing remote right now, so yeah, give us a shout out or being on our contact form.
All right, good stuff, Trevor. Well, thank you very much, and thanks everyone for coming out, and we'll see you next week.
Yep. Bye, everybody.
Bye, everyone.
All right.
Nice meeting you all.
Yep. Good to see you, Trevor. Take care.
You too.